This question basically tells about the relationship between a volume. These questions will discuss. First, we'll understand what is the relation between between 1 mole and volume. 1 mole and its volume. See, 1 mole of any gas, 1 mole of One mole of any gas means what? 6.023 into 10 to 23 molecules maybe, or it may be atoms of that gas. 1 mole of any gas at STP, remember this, huh? STP or NTP. I'll discuss this. What is STP and NTP? So whether it is STP or NTP, 1 mole of any gas at STP or NTP will occupy how much volume? Will occupy 22.4 liter. See, this relation is very straight. 1 mole of any gas, but the condition is what? STP. It should be STP or a NTP. It will always occupy how much volume? 22.4 liter. What is the meaning of STP? STP is a standard. STP stands for a standard temperature and pressure. Right? So what is the meaning of this? Temperature over here is 273.15 Kelvin, which is equal to 0 degrees Celsius, and a pressure is 1 bar. Pressure is 1 bar. What is NTP? NTP is this normal temperature and pressure. Temperature is how much? 293 Kelvin, and pressure is 1 atmosphere. Okay, pressure is in 1 atmosphere. Just stick to this. So whether it is at a STP or a NTP, it will occupy how much? 22.4 liter of gas. Any gas, provided it should be in a gaseous form and it should be STP. So 1 mole of that. So let's solve this question which is asked here. So mark this relation, understand these relations. So here 1.4 gram of nitrogen. 1.4 gram of nitrogen means what? First we have to know the moles, right? So we'll do this first question. 1.4 gram of nitrogen. Before taking the volume of some gas or anything, we should know that what is the number of moles present. So we know that we can use, what is the formula for the number of moles? Number of moles formula. Number of moles formula is a given weight upon, we can say, a molar mass, or we can say, since it is nitrogen, it will exist as a nitrogen gas. N2 is a molecule. You can also say a molecular mass over here. So what is a given weight? Given weight is 1.4 gram. And what is the molar mass of N2 gas? N2 gas, again, this will be provided to you, or a atomic mass of nitrogen given. You should be easily able to calculate a molecular mass or a molar mass of this. This is 2 into 14, which is equal to 28 gram. So this is 28 gram. Unit is grams per mole. See the units. Units are very important over here. So how will write this here? Uh, This could be written as 1.4 could be written as 14 into 10 raised to minus 1 upon 28. So this 4 ones are 4 twos are. And units will be what? It is 1 by 2. Units will be this gram and this gram will get cancelled. What remains is, in the numerator, denominator it is per mole. In the numerator it will be mole. So 1 by 2 is what? 0.5 into 10 raised to minus 1 mole. So 0.05 I can write. This is 0.05 mole of N2 gas. Right? Once we get the number of moles, we can easily calculate what is the volume occupied. So volume occupied by any gas. Remember this irrespective of molar mass. Volume occupied by 1 mole. 1 mole of N2 is how much? At STP, it is 22.4 liter. So what is this 0.05 mole will occupy how much? X liter. So we can do this cross multiplication. X into 1 is equal to 22.4 into 0.05. So this is 22.4 into, I can write this as a 0.05 into 10 raised to minus 1. What is this 0.5? Just telling the trick how to solve this. 0.5 is 1 by 2, no? 10 raised to minus 1. 1 by 2 is what? 11.2 into 10 raised to minus 1. So what is this? 1.12 liter. So 1.4 gram gas will occupy how much? 1.12 liter volume. It will occupy 1.12 liter volume. Hope this is clear. But if you want to go by a formula, what is the formula which you should apply over here? Formula will be what? 22.4 into number of moles, right? Volume occupied by any gas will come back to a formula. If you want to do this using a formula, like we use a cross multiplication. Actually, I use a cross multiplication many times so that you understand the concept. So formula is this: number of volume of gas occupied, volume occupied by gas is equal to what? Number of moles multiplied by 22.4 liter. You can do this, or this is the whole formula. Number of volume occupied by gas at STP, at NTP or STP, at NTP or STP is equal to number of moles is what? We got that number of moles to be 0.05 into 22.4, right? So answer will be what? 1.12 liter. This will be answer. You can use this formula also. Directly you can use this formula. But for that you should know the steps what you need to calculate. First we are calculating the number of moles. Anyhow, somehow you have to calculate the number of moles. Next we'll do with the second question. Again, it is talking about the 6.023 into 10 raised to 10 raised to 21 molecules of the oxygen gas. Okay, so what will be volume occupied by this? So one mole will take this 2. Okay, we'll just change this to 2. So 1 mole of oxygen O2 will have how many molecules? 6.022 into 10 raised to 23. So if this is the case, then what is the meaning of this? What is supplied? You are supplied with 6.022 into 10 raised to 21 molecules, right? So this is equal to x mole. This will be is equal to x mole of O2, x mole of O2. So what is this? X multiplied by 6.022 into 10 raised to 21 is equal to x into 6.023 into 10 raised to power 23. So what is that? X is equal to x is here now. It is 6.022 into 10 raised to 21 divided by 6.022 into 10 raised to power 23. This and this will get cancelled. This is 10 raised to 21. When this will go on the top, it will become 10 raised to minus 23. So this is 10 raised to minus 2 moles. right? So these many moles. So what is the volume occupied by that? Volume occupied, you can use a formula, volume occupied is equal to number of moles multiplied, number of moles multiplied by how much? 22.4, right? So what is the number of moles? It is equal to 10 raised to minus 2 into 22.4. So this will be is equal to 0.224 liter. This is equal to 0.224 liter. Here 0.224 liter. zero point 0.2 moles of ammonia. Second question, zero point 0.2 moles of ammonia. You can of course solve this and you can mention your answer in a comment box, or you can of course, if you're not getting the answer, you can just WhatsApp me on the number which is given over here, right? You can solve this number which is given on the top. You can just WhatsApp me over there. I'll send the solution. Next is we'll discuss about the empirical formula and the molecular formula. So empirical formula and molecular formula. Like for example, we'll take a glucose. Glucose molecular formula is right. It is C6H12O6. Empirical formula is 6. I'll take common and CH2O. Like what is there in the bracket? Whatever maximum I could take common is 6, right? So empirical formula is this, and the molecular formula of the glucose is this. So this is a empirical formula. This is the empirical empirical formula of glucose. Means not 6 into this, huh? You don't have to consider this. Only CH2O is an empirical formula. And this is a molecular formula of glucose. This is molecular formula of glucose. Now from this we can understand that empirical formula just tells about just tells about the ratio in which all the atoms in which a different types of atoms are present in molecule, right? Means over here ratio of the carbon, hydrogen and oxygen is what? Here nothing is there, right? I have not written, means it is 1, no? And here also it is 1. It is ratio is 1 is to 2 is to 1. It is just telling the ratio of the carbon, hydrogen, oxygen. It is an empirical formula. And what is the molecular formula? Molecular formula tells about actual number, tells about actual number of atoms present in a molecule. Means directly it says that there are 6 carbon, 12 hydrogen, and there are 6 oxygen. So this is the difference between the empirical and the molecular formula. We'll take more examples. We'll take up more examples. Like if we write a molecular formula of H2O2, hydrogen peroxide, what is the empirical formula? You can take maximum 2 common. So HO is the empirical formula. Benzene, C6H6. You can take 6 common. So HCl. CH is the empirical formula. We can take examples like H2O. H2O, you cannot take anything common. So here empirical formula is same as a molecular formula, right? So it is this way. So what we can write is that a molecular formula, we can also write molecular formula is equal to N into empirical formula. This is what a relation we can use. This could be also changed to molecular mass formula mass is equal to N into empirical formula mass. You can use these relations. So let's take one problem over here on this basis. Okay, let's solve this. The question is compound contains 4.07% hydrogen, 24.27% carbon and 71.65% chlorine. Its molecular mass is given, means molar mass is given of the given compound. What is the empirical formula and molecular formula is asked in this case? So what we'll do is they have given the percentage. Whenever percentages are given, it's very easy. It become question becomes more easy. Understand that, okay? You shouldn't be getting scared after looking at the percentage. Many times students feel that, okay, some percentage is given and it will be a very difficult for me to solve. Okay, remember that percentages is given. So what they are saying is compound has I'll write the elements. What are the elements present? Okay, 1 minute. I'm just checking. I'll keep this window here. This window I'll put here so that we can use whole of this space. I'll write over here that elements. First I'll write elements. Then I'll write percentage. Then I'll write next column is for weight. I'll be converting all these weights. Then I'll write number of moles. And then write simplest whole number ratio. You should also make this column while solving. It becomes more easy and looks systematic. Where what is very important while you write your subjective paper, a systematic, how neat you are, that also matters. Remember this. Your writing skill, how do you write this? Okay, you should be presentable. Always it is very important. You should be a presentable. Okay. So there is a hydrogen. See, you may be knowing the concepts very well, but if you don't know how to put it in the paper, it is of no use. Remember this. So this is a hydrogen. I'll consider this. Then I'll consider next is carbon. Okay, hydrogen is H, carbon is C, and then last is chlorine. Um, chlorine is chlorine is Cl. See, percentage is given. A compound contains. There is a compound. Let's say there is a compound. There is a compound this way. Okay, this is a certain percent, this is certain weight. We don't know what is the weight of this compound. But in this compound, what they are saying is that in this there is how much 4.07% hydrogen. There is in this case in certain weight there is a 24.27% carbon, and what else is there? 71.65% chlorine. All these things are there in certain weight, right? So this weight I can decide. Like how much you will decide? I decided to be 100. A reason for this, choosing the weight of this compound to be 100, my calculations become easy. You can choose 200, you can choose 500, 1000, you can choose 150, you can choose 75, 25, any number. But for you to calculate 24, let's say you are choosing it to be 300, you will have to write a 24.27% of the 300. The calculations become more and more tough, right? So what we do is we choose a total weight of the compound to be 100, and that's why I'll write a percentages. Percentages, what is given is 24.27%. Then this is sorry, not 24.27. Hydrogen is 4.07%. Then it is 24.27%, and this is 71.65%. So what is this 4.07%? If you have considered this weight to be 100, it is a direct conversion. 4.07. This is 24.27 gram. This is direct conversion. And this is 71.65 gram. Direct conversion it is. Yes. So otherwise, if you are not choosing this to be 100, then you have choosing, let's say, 200 or 300, you will have to calculate no 4% of 200, 300. So that's why I am recommending you should choose this to be 100. That's why this direct conversion. So what is the number of moles over here of the hydrogen? The atomic mass of the hydrogen, number of moles, atomic mass of hydrogen is 1. And what is the given weight? Sorry, number of moles we are finding, no? So it is a given weight is 4.07. I have taken. What is the molar mass? 1. So this is equal to 4.07. Number of moles over here is what? Given weight is 24.27 and carbon is 12. And what is number of moles over here? Given weight is 71.65. 71.65 upon molar mass of the chlorine is 35.5. See, these molar masses and all these things will be provided to you. You don't worry about these molar masses. Don't buy heart. If you can remember, well and good. So, what is this answer here? 24.27. 24.27 divided by 12. This comes to 2.022, and this comes to 2.018. Now, among this, which is the smallest number? 2.018 is the smallest number. We will be dividing it throughout all to get a simplest whole number ratio, not ration. This is ratio. So, what is that? It is 4.07 divided by, this is smallest, 2.018. Here it is what? Um, 2.022 divided by 2.018. This is 2.018 divided by 2.018. This approximately will give you answer to be is equal to 2. This is also is equal to 1. This is also approximately is equal to 1. So here, what are the ratios we are getting? We are getting the ratios of the hydrogen to be is equal to 2. Carbon I am getting 1, and the chlorine I am getting is equal to 1, right? So CH2Cl is the empirical formula. Empirical formula is CH2Cl. I'll call this to be CH2Cl. What is the empirical formula mass? It is 12 plus 2 into 1 plus chlorine is 35.5, right? So this is empirical formula mass. So 12 plus 2 is 14 plus 35.5. That comes to 49.5, right? This is empirical formula mass. So N is equal to what? N is equal to, like, we have this relation, right? We need to find N over here. So empirical formula we have got. Find the empirical formula. This is the empirical formula. Empirical formula mass is this. So what is molecular mass is equal to N into empirical formula mass, or empirical mass, we can say empirical mass. It is one and same. So molecular mass is given, so therefore N is equal to what? Molecular mass upon empirical mass. So what is that? N is equal to, what is the molecular mass given? Molecular mass is given to be 98.96. 98.96 divided by empirical mass is 49.5. So this will come to approximately is equal to 2. So N is equal to 2, right? So we are getting N is equal to 2. So what is the molecular formula? Molecular formula will be is equal to N into empirical formula. So N is equal to 2 and empirical formula is what? CH2Cl. So it is C4, C2, H4, Cl2. This is what your answer is for your molecular formula.